Hi there. So today it's supposedly a new topic. It's called hypothesis testing, but actually it's just a continuation of cumulative probabilities, which is what we've already been looking at. And it's about how we formalize how we go about interpreting the results that we've got in order to be able to say whether or not we think something is really at the probability that we think it is. Makes much sense? Maybe not. It's a slightly confusing topic at times. You've got to take your time. I would suggest start off by copying down the two definitions we've got behind us for the null hypothesis, which is what we're saying we think is true. But we also need to have an alternative hypothesis, which is the thing we're going to have to adopt if it looks like what we thought was true maybe isn't. Right, so here's our first example. John's tossing his coin 8 times. Now if you flip a coin 8 times, how are you going to know if it's biased or not? You're going to have a suspicion, but it is possible, and people have done it, to toss a coin 10 times in a row and get ahead. You're probably going to have to spend a whole day doing it. It'll take hours and hours and hours until you get a time where a fair coin does this, but it can happen. So we're talking about looking at what's probably true as opposed to what you know to be true. Anyway, if you're asked this, it's a technical term, what is the test statistic? Well, what that means is, what is it that we want to get from the test? And it's simply the number of heads that he gets. That's what John's counting, isn't it? So that's all we need to put down for that. And the next thing we're going to need to start to do is think about these two terms that I gave you before, the null hypothesis and whatever that other one was. So next up we need to write down a suitable null hypothesis. So what are we assuming? Well, generally we're going to assume that the coin isn't biased. So the null hypothesis is going to say that. And the first thing we need to write down is HO, down at lower point like that, hyphen, and that means the null hypothesis. And what we're assuming is that the number of heads that we're going to get, our test statistic, is going to be 4, isn't it, out of 8, but we're not saying that. What we're saying is the probability is a half, or is 0.5. Now he could get 6 heads and it would still be okay. Maybe, we're not sure. But anyway, what we're trying to prove is that the probability is 0.5. Now, what was that other thing I was talking about? It's called the alternative hypothesis. And you may remember that this, we start by writing an H with a 1. So 0 is for the thing that we're assuming to be true and that maybe we want to be true, maybe we don't, but maybe we do. And then the alternative hypothesis is going to be what would be true if it wasn't. Now, if we look on here, it was saying that John reckons this coin, maybe he's already flipped it a few times before, he reckons it's either unbiased or it might be biased towards heads. For some reason, he doesn't think it's possible that it's biased towards tails. So we're talking about that probability. Now, if it's biased towards heads, that probability, that test statistic, the number of times, is going to be working on a probability of better than a half. So the probability is going to be larger than 0.5. Now, what does all that mean? As far as this example is concerned, I just wanted us to think about, well, where would we take this if we were going to be asked some more questions? We won't in this case, but let's have a little look at it. Well, we would want to be turning on our calculator and going to statistics, going to distribution and binomial, and going with the cumulative distribution. And now we might be saying that what would be the probability that I get 8 heads, so lower being 8, upper being 8, number of trials is 8, and probability is 0.5. If I press equals on that, I get, well, that would be 0.0039, wouldn't it? So less than a 1%, way less than a 1% chance of that happening. So then I might say, well, what if there was 7? Oh, I've gone the wrong one there, haven't I? Upper of 8, a lower. Oh, how do I do that? Hang on. Lower of 7 and an upper of 8. That's giving me 0.035. So suddenly that's a 3.5% chance of that happening. So if that happened, you could say that I was, what's 3.5 away? That's 96.5% sure that it was biased. But I wouldn't be totally sure, but I would be pretty sure. Whereas if we just went back one more and changed it to 6, this is saying there's a 14% chance of that happening. So 6 heads, that's probably not enough for me to think, yeah, or for John to think that yes, this is biased. But of course it still could be. Right, so I'll pause the video and write the question down and get as far as you can on this. So your suitable test statistic is going to be how many people support the election candidate. It says that she reckons she's got 40% of the residents, and the researcher has asked 20 people whether they support her or not. So 3 people say that they do. So so the suitable test statistic would be the number of people who say that they do, which is 3, isn't it? Right, now, hopefully you don't have as much difficulty writing the word candidate as I did. Next up, the 2 suitable hypotheses. Well, first of all, there's your null hypothesis, which starts like that, doesn't it? Now, the probability has got to be 40%, so that's going to be saying that P is equal to 0.4. And your null hypothesis, this time they're saying whether or not the candidate is overestimating her support. Now, if she is overestimating, so the null hypothesis is saying she isn't overestimating it, she's got it right. So if she was overestimating it, she would not be getting as much support as that, so the probability would have to be less than 0.4. And finally, the condition under which the null hypothesis would be rejected, well, that's going to be if the number of people 3 is so low that it's got a less than 5% chance of happening. Which looks something like that. Now, what they haven't asked you to do there is work out whether or not it should be rejected, which would be the next thing to happen. It'll happen next lesson, but I thought I'd show you that anyway, since they've given us the data on it. So what we would do, therefore, is we would say, right, I want to have my lowest number of people, because it's going to include those with none, those with 1, those with 2, and those with 3. My upper number of people supporting is 3. The number of people being asked is 20. The probability is 0.4. Now the chance of that happening of only 0, 1, 2 or 3 people is apparently 0.01596, which is just over 1.5%. And that is not as much. So actually the null hypothesis would be rejected here, and they would say that the candidate was overestimating her support. Okay, so here's the first of 2 examples I'd like to have a go at. So pause the video, give it a go. So the mistake that Shell's made is that she has said that the test statistic is the probability. It's not the probability, it's how many times it happens. And then the null hypothesis is going to be HO, and the probability for an unbiased coin would be 0.5, so that'd be your null hypothesis. And then your alternative hypothesis would be that it is biased. Now, this time, we're not saying that she thinks it would be biased towards heads or tails. So we'd just be saying that it is not 0.5. Okay, and that is a case of, in that case, we would be interested in, we'll start looking at curves like this a bit more in the future, but she would be interested in those areas and those areas there. But we will talk more about that another time. Okay, last example coming up. Right, so here's your last example. Have a full go at this. And if you can, see if you can work out the final probability for the last bit, even though that's not asked for. Right, so your suitable test statistic is going to be the number of faulty articles that can be found in the sample. And your two hypotheses. We'll start off with your null hypothesis, which is always going to be the assumption that nothing has changed. So the probability, according to that, is 0.1. So that's all you need to do. Then your null hypothesis is that that's no longer true. Now, they're saying whether or not there's been a reduction. So that would be an improvement, wouldn't it? But that still means rejecting the null hypothesis. So that would mean a reduction means that the chance of finding a fault would be less than 10% or 0.1. Now the condition under which the null hypothesis is rejected is something along the lines of this. The probability of finding 8 or fewer faults would have to be less than 5%. Now, is that what we've got in this case? Well, 0 being the lower, 8 being the most faults we could accept out of 100 with a probability of 0.1. The probability of that happening is actually a whopping 32% chance. So there are not a small enough number of faults to be able to say that's okay. I mean, it is less than you would expect, because if I was to draw a little curve here showing us what would happen between 0 there and 100 there, the most likely number would be 10, wouldn't it? So that would be there. So we would have a curve doing something like that. And what this is saying is 8, which is about there, the probability of an 8 would be 32% in there. That would have to be a much smaller amount, down to 5%, for it to be true. But more of that next time, folks. Cheerio, everybody.